Now, what I'm going to talk about right now, first of all, I hand drew everything up on the board, so it's not perfect, but I want you to listen to the concepts that I'm talking about. That is the main part of what I'm going to tell you here on this one that's similar to number 4. Now, the first thing that we're looking at when we've got this parabola on this graph, it says, what are the solutions to the equation? Well, the solutions are going to be where the graph intersects the x-axis. Now, the x-axis is the horizontal axis. The vertical axis is the y-axis. So I want to see where my parabola here, in this case, is intersecting the x-axis. It's intersecting there and there. That is -1. So x equals -1. And here is a +7. So it intersects at -1 and +7. That tells me that those are the solutions to my equation. -1 and 7, because the parabola intersects the x-axis at -1 and 7. Does this function have a minimum or a maximum? Well, in this case, this looks like a cup or a glass or a bowl. And since it will hold the water, it's got a bottom down here, so it has a minimum. If it were upside down like this, it would have a maximum. All right, what are the coordinates of the vertex? Well, the vertex is this minimum, and if you'll look straight down here, I'm going to draw straight down. Now I noted this point is -3, this is -8, I'm sorry, and this is +3. So the vertex, I'm going to write right here, would be 3, -8 would be the vertex. And the line of symmetry is the line that splits this parabola in half. Again, my drawing is not perfect, but the line of symmetry would be x equals 3 right here, okay? Because it splits that parabola exactly in half. The vertex is 3, -8, and it is a minimum. Pretty simple. There's some good examples in the book and online on these types of problems, but sometimes it's easier when you hear someone say it. The next thing we'll be looking at is an example similar to number 5.